Graphene is about 150 times more conductive than silicon, which means you can have 150 times more the performance if you can get it in its perfect state. But also, it uses 1,000 times less power. So 20% of the world's energy is being used by computing right now. Less than 2% if everything was made of graphene. That's the impact we could have. That first realization that, this is serious, this is real. People really believe in what we're doing. They really believe enough to take some of the things that they have, some of their value, and put it into our business and into the people. You'll have heard that saying before, that VCs and angel investors generally don't invest in the idea, they invest in the people. A lot of people assume that the culture between the UK and the US is very similar. We speak the same language, but actually the cultures are very, very different. The elevator pitch is a US thing. 3 minutes, tell me what it is, get it all into that nice package, and I understand what you're doing.
Hello, and welcome to Scaling Green Tech with Catherine Keddy and Matt Jaworski, the co-founders of Adopter, the marketing agency for climate tech and adaptation. We take you behind the scenes of the climate tech's most inspiring journeys, from breakthrough scaling wins to game-changing innovations. Join us for practical lessons and stories from the founders, investors, and changemakers who know what it takes to solve some of the world's biggest problems.
So welcome back to Scaling Green Tech with me, Catherine Keddy, and Matt Jaworski.
Hello, hello.
We are here with Dr. Simon Thomas. He is the co-founder and CEO of Paragraf. And we're here today to explore how he's taken his company from a startup all the way to a very substantial Series C tech company. Thank you so much for joining us, Simon.
Oh, thank you for the opportunity, Kat and Matt. Lovely to meet you.
So our first question that we always ask, which I think stumps some people, is how would you describe your technology to a 5-year-old?
Wow, to a 5-year-old. I've only asked for a 10-year-old before, but 5-year-old. Paragraf is all about materials. So one material in particular at the moment called carbon. So we produce massive layers of carbon onto substrates that we can then turn into chips. Carbon's a really interesting element, if you like, because if you think about it, you use it in pencil, so it's really soft in certain forms, so you can write with it. It's in diamonds, so it's really hard in other forms when you think about it. And we're all made of carbon, so it's a really interesting element. So when you use it the way we do, in very, very thin forms, you can make very, very fast electronics. So for a 5-year-old, this means even better games machines or even better mobile phones, as 5-year-olds seem to have mobile phones these days. So yeah, we're working in a materials sphere that's trying to advance electronics so that your 5-year-old can have better games time, I guess.
I remember my grandfather explaining to me graphene when I was 10, 12 years old, so some of that rings a bell here. Now, what about the adult version of the overview?
Sure. So graphene's been around since 2004. It was isolated in the University of Manchester, and it was the first time that somebody made a single layer of atom material. When they did that, they realized that when they tested the properties of it, it was the best conductor in the world. So we had a load of explosion of experiments and investigations and inventions in labs that showed that graphene, when you put it into electronics, could do amazing things. But all those amazing things couldn't come out of the lab because the graphene itself was very difficult to manufacture. Our USP, if you like, and our invention was the ability to create the graphene direct on a substrate that you could then insert into the manufacturing chain of chips. So it's that core ability to make the graphene that really kicked off Paragraf. Beyond that, we started to invent the ways that you could use the graphene in those chip building systems. So there's lots of IP in how you actually apply the graphene. There's lots of IP in how you actually get it to work as a device. But essentially, if you boil it down, what we've done is we've put a new material into electronics, replacing things like silicon and gallium nitride and compound semiconductors. And we're using the properties that graphene delivers, very, very high conductivity, to create much higher performance and much lower energy consuming devices. So really, we are akin to a semiconductor company, but we go all the way from the materials construction through to the end chip. So we call it an integrated device manufacturing company. And we just launched our first foundry here in the UK at the end of last year. And in fact, it's the first graphene foundry in the world.
Why has it been so hard to commercialize graphene up until this point?
Well, it really goes back to that graphene manufacturing point. Imagine graphene is, a single layer of carbon atoms, and you want to make a very large area of this. How do you make a very uniform, large area of single atoms? So the challenge was, how do you make that crystalline material across this large area that you can then use in electronics? So that breakthrough of being able to make that really uniform, really high quality graphene was, you often hear about this challenge of lab to fab. And it's the same for a lot of materials. And it's a really difficult challenge. I mean, even if you look at silicon going back into the 1950s and 60s, it took a long time before people got really good devices out of it. The same with compound semiconductors in the 70s with indium gallium arsenide. It took a long time for people to understand how to use it properly and create photonics, for example. Same challenge here. Overcoming that ability to go from the small scale device that you can get PhD students to make into that large scale that everybody wants to buy is a really difficult challenge, because if you think about it, Paragraf's one of the hardest prospect companies you can think about. You want to make a new material. You then want to make a device out of it. You then want to scale it. You then have a manufacturing company, and then you have a global commercial organization. So it's got all the challenges. We're not just making one widget. I like to think about we're actually creating a whole new industry. And so the challenges have been quite big to go through each of those gates, but really we wind it all the way back. It's that invention that happened in Cambridge University that really started it all out.
When you began your journey with this company, did you originally imagine this very kind of complex business with multiple layers of manufacturing capacity? I think a lot of early stage companies come in with new materials and they say, I'm going to stick to being a materials innovator. That's what I'm good at. That's what I've built. Did you start there and then grow, or did you have this vision from the beginning?
It's a really interesting question. It really goes back to when we span out of the university. After we first created those layers of graphene, we weren't really thinking about making a company. What we were thinking about was the breakthrough we'd made. University is all about creating new knowledge, new innovation, putting it into papers, sharing it with the world. What we realized, though, is that had already happened. There'd been lots and lots and lots of papers written about graphene because it's been around for 15 years. And people had already done that innovative, publish in Nature, publish in the science journals. And so we looked at it and went, well, what are we going to do with it? We could, of course, publish and show the best quality graphene ever, a new technique. But we started looking at those inventions that people had made and we went, well, if we went a bit further, we could actually start making those really great innovations into things the whole world could use. And so at that point in time, we started to think about what you were saying there about having graphene, but then having devices. So I guess the inception of that idea that we would have a company that wasn't just materials was there to start with. Whether we actually thought about how wide it would go, I would say probably not. Because once you get to the company level and you've gone through your seed financing and you're able to show the world that you've done the tech transfer from the university, you then get lots of people asking you to do lots of different things. And of course, internally, you have a lot of scientists that have a lot of great ideas as well. So focus becomes, at least in the early years, a really difficult thing to keep. But then you look at the markets, they come in, people start demanding what they want from the graphene, and then you start to go down different commercial avenues. So it's kind of like a tree. You start with the graphene, which is the trunk, and then you start to branch out into, we could make this and we could make that. But honestly, no, I don't think we did understand just how far it would branch, if you like, over the years that came after that invention.
And when you were starting the company, having been a scientist, how did you find the switch to being a founder, to being an entrepreneur?
Well, actually, I was very fortunate because before I joined Sir Colin Humphreys at the university, I spent 12 years in industry. So I worked for a semiconductor equipment supplier, but my role was in material science. So I'd spent quite some time in the industrial commercial environment. So it's not like I was a PhD or postdoc that just spun out with no experience of the commercial world. So I think it was a little bit different for me than I would have a normal spin out, but still it was a challenge, right? Even when I was working for the equipment company, most of my time was spent in fabs, in labs, doing technical work. In fact, a lot of it was spent on getting machines to work. So when you turn, if you like, your attention away from the technical side into leading the business, it is a challenge. It's a mindset change. You've also got to remember, in the first few years, I was still heavily technically involved. The tech transfer from the university, getting the first layers to work of the graphene, getting the first devices made. I was still really kind of embedded in that. So it's not like one day you're doing tech and the next day you're turning around and you're running a company. You're actually in a situation where if you're lucky like I was, you start to feather away from it. So it doesn't feel like such a massive impact. But I still do miss it though.
And I guess you mentioned a mindset change. So what exactly was it?
There's a few factors that come in. The first one is you've got people's money that you're looking after. And they
that is after you raised that money from those people, right?
Yeah. It goes through stages. And I think the mindset change of understanding what is a valuable asset is probably the first thing that you have to do. And universities are doing really good things on that at the moment with the tech transfer offices, helping people who want to spin businesses out understand what that business plan means, what the asset means. And so that first part already starts changing your mind, because you're not just thinking about being in a lab in Cambridge University. You think about, how do I convert this into a plan? How do I put this in front of somebody and make them believe I can achieve it? So you get that wind up at the start. But then when you get past the financing, you end up in a situation that is, I went through an experience that was quite interesting. When we closed our financing round, our first financing round, we went for dinner with all the investors, and I invited all of the investors to come. And we had some institutional investors, so we had some VCs, but we also had some people that had put money from their own pocket in. And I remember sitting there at that first dinner going, this person's put money into a company. I started to get those cold sweats of, what if it doesn't work? This person's just given me some of their life savings. So you go through a kind of worrying period to start with, and then you start to realize that actually they're putting trust in you, which is a great thing. They may still put some pressure on at a later date to make sure you're moving in the right direction. But that first realization that, this is serious, this is real. People really believe in what we're doing. They really believe enough to take some of the things that they have, some of their value, and put it into our business and into the people. You'll have heard that saying before, that VCs and angel investors generally don't invest in the idea, they invest in the people. So when you start to realize that and you start to think, okay, we're trusted, we're going to move forward, then it starts to become a little bit different. But then you start employing people. And then all of a sudden you've got a different concern, because actually you've got people's livelihoods in your hand. And so from day to day, you start to learn how to cope with not worrying too much about their livelihoods, but worrying about whether they're having an exciting time. Because at least if you can't give them a 10-year or 20-year job, what you can do is at least give them somewhat fun to work. Give them a place where actually it doesn't feel like they're working and they're enjoying themselves. And so you start to turn from worrying about yourself and the invention and the technology into actually being much more focused on people and what they can deliver and how you can help them. And then you start to grow the business a bit more, and more financing comes in, it becomes more serious, and then you're dealing with a lot more people, investors or more employees, and then you're dealing with customers. And so before you know it, that technical part of your brain is being pushed back by the other stuff, because you've got to look after the business. You have a fiduciary responsibility as the CEO.
Yeah, whenever anyone asks me, when did our business feel like it was real and substantial? Like, when did you feel like a business owner or an entrepreneur? I think it was absolutely when we hired our first people, because it's just such a big transition. Like the business is bigger than yourselves. and then your concerns get greater, but your opportunities get greater, etc.
Yeah.
You've hinted a little bit about your fundraising journey, but I'd love to hear a bit more about it. Who did you raise from? When did you raise from them? Have you got any lessons for people listening who are founders looking to raise Series A, B, C?
I mean, something that I would be also interested on the marketing communications angle is how your sort of messaging positioning changed between the rounds to also match what investors are looking for.
Wow, that's a big one. Yeah, I generally, the financing rounds, as the business has grown, I generally look at different phases of the company. It aligns quite well in the growth spurts that you have. Of course it would, because the capital injection is what allows you to then to grow further. The seed round, which was our spin out round, if you like. I know there's a lot of companies that have pre-seed rounds now. There's good reason for that.
I guess I heard also in States, especially some companies do pre-seed rounds because then it makes their seed and round A rounds sound even more impressive.
There are multi-factors, actually. That is one of them, definitely. But also the parameters that are being applied to each of those named rounds are different now from what they were 10 years ago. So if you want to raise a Series A today, most investors are expecting you to have revenues. That wasn't the case. It used to be Series B or Series C, you were in the revenue stage. But because of the changes in the financing landscape, particularly from 20 to 24, maybe into 25, the investment landscape became very strange. And so now even early stage investors are looking for revenues as a start. So, well, if you're looking at Series A, well, let's put another round in front of the seed. So you've got more time to get to that point. There are a few other factors as well. But yeah, that ability to advertise a massive Series A is obviously one of them. But yes, when we spun out of the university from our seed round, the narrative was very much around making the material, having the ability to transfer it from the university into a stable business. So our narrative was really around that we could take what was in the business and put it somewhere else. And if you think about it, that's a really big milestone, because if we can do that, the value of the material production, the value of those early stages could very easily be realized by somebody else. I mean, we're a university spin-out. If somebody like Samsung decided to do it, then so the investors see value in that. Even if we were to not do so well, there's an asset there that can be. And so the narrative is really around your capabilities as the team and the people you bring as your first employees. Very fortunate in Cambridge that there's a deep tech investor environment that's so deep. It's not surprising being around Cambridge University. Right? It's the same in Oxford as well. Right? And of course down here in Imperial though, where you've got those experts, they can understand the technology that you're trying to bring to market. And so you have tech funds that can really understand what you're saying. So our first investor, if you like, our first believer, was a deep tech company in the centre of Cambridge called IQ Capital. When we pitched to them, they were very interested in it, what we were doing, and that then kind of snowballed into talking to other investors in the Cambridge ecosystem. So our first round was focused around those early stage VCs in Cambridge and in London as well. So that was didn't have to travel around the world to find all your investors. You could get on a train and all within a triangle, you could easily do it in a day.
And then they can all join you for a dinner.
Yes, they can. Whenever they want.
Bang down your door.
Yes, that's the other problem. They're only a car journey away. No, we have a great relationship with our investors, which is one of the things that's helped us a lot through our journey. Keeping your investors on board, keeping the people that are also carrying your belief out into the outside world as well is a really important factor. So that first round drew in Parkwalk Advisors and Amadeus, and the university investors as well through Cambridge Enterprise, which was great. So the narrative there was around showing capability for us to be able to spin a business out, but in such a way that what we were doing in the university existed outside. There were a few complications that probably we don't need to talk about today, which is to do with tech transfer offices. They've got much better now. I know it's a whole subject that people like to talk about, but they've got much better now. But back then it was a bit of a challenge. We then went into very rapidly we went into our Series A. Our Series A was closed about 18 months after our seed round. And the reason for that is that we managed to do very, very rapid tech transfer into the facility we'd got. So our messaging then started to become around what's the product we're going to take to customers. So we wanted to raise that Series A round to bring in the talent and the equipment in order to be able to get product at the end of the line that we could put into the first customer's hands. Because if you think about it, the graphene's not really a product. It could be. You could be a material seller, but that's at the low end of the value chain. So we wanted to push beyond that. And so we raised some capital. We raised about 16 million in capital to bring more equipment in, to bring more people in. And that was all about having the objective of getting those first MVPs into customer hands. And so it's a very clear story at this point. We've got the graphene, we're going to do the tech transfer. We've done the tech transfer, we're going to raise some capital to get some product out. So nice and easy. And so talking to more investors that understood deep tech, and all of our investors followed on at that point. And then we brought in some other people, which turned into a widening of what I would call the UK ecosystem investors. So Malton Ventures joined us then, or Draper Esprit as they were at the time. That allowed us to get a product into the market, take it to our first customer, get it tested, and allow people to understand that what we'd actually done was real. So I'll just pause at that point because you may or may not know graphene had a really bad reputation. So after it was created in the university, a lot of people put a lot of money into it because they thought we can make all these fantastic things. And a lot of people lost a lot of money.
It reminds me of the stories I heard from scientists who were in any way involved with synthetic spider silk, that there was a lot of hype, a lot of money raised, but so far no real world results, and it doesn't want to come together.
Yeah, we have, absolutely. And we have another adjacent technology to that called carbon nanotubes, which actually were incepted in the 90s. And they are fantastic, but manufacturing them is in a way that can incorporate them into chips or electronic technologies is really difficult. Even when you made them, incorporating them is even more difficult. You can't use standard equipment sets, which again comes back to the big USP of Paragraf. We can use standard equipment with our graphene, and that's the breakthrough, if you like. But yeah, that you're absolutely right. Getting past that mindset of we can make chips now, and we can have a customer that can tell us whether they're good or not. Fortunately, they said that we're good. So at that point, it was going through those gates, those early stage gates of product proofing. We then came to our Series B round, which turned into a $60 million raise. The reason for that is because we needed to then push on and create not MVP, but a qualified product. And this is where we started to engage with the world, and the world came back to us and said, well, can you do this? Or can you do that? Instead of the device that you're making, this might be more profitable. And this is where that tree started to grow. And we ended up with some serious decisions to be made on where we wanted to take the product route, where we wanted to take the company. And that's where the inception of the Foundry model came in. So Paragraf's vision is to bring graphene into the world of electronics so that everybody can use it. So everybody can harness the properties. You can't do that if you're selling a single product. You have to be able to offer the underlying technology to create the graphene and to put the graphene into end products. So that round of 60 million was the start of Paragraf's real vision, which was creating a foundry where people can come to us and say, can you build this for us? So that was a $60 million round. Yes, I'm quoting dollars because we had to get an American lead, which is not unsurprising. The capital landscape in the UK is fantastic, as I've just explained for our first two rounds, for the early stage innovation. Not so great for when you're going to the larger scaling point. risk appetite is very different. So we brought in a lead called New Science Ventures, who basically led that round, and all of our investors again followed on, which was great again. This is where I talk about having the great support of the investors you've got at those early stages, and a couple of other people joined. So we then looked at how we were going to turn Paragraf into not just a graphene electronics company, but a graphene electronics foundry company. So that's when we acquired at least the building for our first foundry, which is in Huntingdon now. Went through a lot of processes of getting that sorted, getting the equipment into that second site. And then at that point in time, we also then went through a process of acquiring a US company. There's not much graphene expertise in the world. There was a company in the US that had a lot of expertise, and we thought this is an opportunity. And they had an adjacent technology to us, and they had some IP. They just didn't have the way to make the graphene like we did. So we had that advantage, and we bought that company, expanded into San Diego. That was quite a difficult time for very different reasons, because we're scaling something that really is difficult to scale in the UK. There isn't really the infrastructure or the landscape or the talent to be able to do that easily, which then led into our Series C round. So our Series C round, which we closed last year, was another $55 million. That was led by Mubadala, who are Emirati. We're looking now at how we roll out that foundry model. So we have a manufacturing site here in the UK. We've just opened up a subsidiary in Shanghai. We're opening a subsidiary in Abu Dhabi. And so we're going global now. So this raise was all about getting our product to a high yield in a foundry, but also expanding Paragraf's reach around the world, customer base, and also partner base as well. You don't have a foundry without partners. You can't just have a customer who goes, I want that. You have to work together with them and say, well, how do you want it? How would you like it making? What's your end goal? And so that's what we're doing right now. And I'm very happy to say, we closed our financing rounds last year, and we also got our first wafers through the foundry in December. So we have true proof that you can make commercial scale graphene electronic devices, which has been the journey for the past 8 years.
Amazing. Congratulations.
Thank you. Thank you. It's been an exciting, stressful, interesting, and highly, highly challenging a few years, but to see what we get out the far end, that's the real goal.
I mean, a lot of people said it couldn't be done. When you were speaking to those investors at each stage, do you think that the challenge of previous failed technologies and people being burnt kind of lessened as you grew more traction? Or even at your Series C round, are you still getting people going, graphene doesn't work, it doesn't work at scale, it's got this bad reputation, we're seeing this as kind of overhyped technology innovation?
Absolutely. We've had the same challenge all the way through our financing rounds. Graphene has got a black mark against it. I think that's being carbon. I don't think you'd say a black mark, so unless it's got a red mark against it. The belief that you can actually make things from it, not just the graphene itself, but you can actually make something from it, was the real challenge. Over $2 billion was put into creating graphene by Samsung. And so when you look at that statistic, and there's a couple of other companies that spent billions as well, and then put on top of that all the investment that went into graphene, I understand why there is inertia. But we've always believed what we can do. We've seen what we can create as we go through each stage, and they are growth stages. The tech transfer was small. Going into our first device was small. Going into now the foundry, we're going to larger scale. We've been fortunate with the investors that we've had. We've been fortunate that they've understood our technology and our belief and our vision and the purpose of the company to carry us through that path. However, what happened in December was the big trigger. Getting 6-inch wafers of graphene devices through a full semiconductor line without any problems on the semiconductor line and actually getting our first wafers yielding devices, which is almost near on impossible, has changed that narrative overnight. I now have investors approaching me continually. So I'm going into a Series D round in the not too distant future, but it's a very different Series D round. Instead of me having to really push the narrative, I have people knocking down the door. And it's that crux point, that point of showing it works, that's been critical. It's taken $150 million to get it to the point where it works. But if you compare that to other semiconductor companies, that's nothing. So it's a new era for us now. It's a very exciting era. I'm not sure I can retire yet, but
It's just getting exciting.
Yeah, why retire now if you could, if that's what you've been waiting for?
no, it's there is still a lot of journey to be run. So yeah.
So I would love to hear more about what the applications of your technology are. Like, what does it mean for everyday people, health-wise, climate-wise? Talked about quantum, talked about AI. Tell us what that looks like.
Yeah, it's very exciting. That hurdle I talked about putting graphene into devices is kind of opening Pandora's box.
Right.
And the reason for that is the graphene material itself has got so many wonderful properties that it can be integrated into so many different areas and give a performance advantage. So to just give you the underlying kind of parameters, graphene is about 150 times more conductive than silicon, which means you can have 150 times more the performance if you can get it in its perfect state. But also, it uses 1,000 times less power. So if you imagine today, data centers are kind of the big red flashing light that's going on around the world because of the amount of energy that they're using. The statistics are horrifying. I think it was in 2020, global data centers used more energy than the whole of the UK. That was in 2020. Imagine what it is now. That was when data centers were just kicking off and we didn't really have all the AI stuff that we've got now. In fact, I think that another statistic was that Bitcoin mining in 2020 used more energy than the whole of Argentina. So you can see the demands on computing tech. If we could get graphene into those types of devices, into logic, into chips, into memory, the parameter that I talked about before of 1,000 times less energy that we've actually proven in some of our devices will exist in whatever device you put it into. So 20% of the world's energy is being used by computing right now. Less than 2% if everything was made of graphene. That's the impact we could have. Adoption of the material is the critical parameter. But going beyond that, graphene has properties that are more than just being able to create faster or higher performance or lower power devices. Because of the way in which the structure of graphene works, you can also create devices that have been speculated for many years. One of them I've got in my pocket here. I don't know whether it's...
Oh, I was wondering if you'll bring something to show us in the
You did, but I carry it in my pocket all the time. So that...
You hold it up to the camera.
I forgot to bring a wafer. In the center of that black dot is a graphene chip. The rest of the PCB is meaningless, by the way. It's just so you can hold it and plug it into something. But right in the center is a graphene chip. That graphene chip is set up to detect potassium in blood. So today, if you want to have a potassium test, you have to go to a clinic, you have to withdraw blood, it has to get transported to a lab. So generally, everything is done in labs. Same for other tests. I'm sure you've been to doctors and clinics and hospital and had blood taken before, and it gets sent off to a lab and you get results later on, the time depending on how critically ill you could be. That device allows you to put a drop of blood on it and detect potassium in 20 seconds. So it's taking all of that chain of whether it's you needing to give 2 vials of blood, which is not nice, it being transported from the clinic or the hospital to the lab, all the lab time and energy it takes to do that. It then, the computing power required to get all of the information back to you, and then you understanding the results, probably even involving a doctor to explain it to you. That allows you to put a drop of blood on it and the computer says yes or no, or what level it is. So that type of device can fundamentally change how we do healthcare forever. If you can have devices like that, you can monitor your health continually. You don't need doctors. You don't need to go to hospital unless you've got something seriously. That's what graphene can do. And that's just one simple example. So we're going through a process, that's one of our main products at the moment. We're going through a process now getting that out into the world. But if you think about it, it's not just about testing of medical diagnostics, making sure everyone's healthy. You can put it into wearables, so you're monitoring your health every day. So it's about wellness as well. But we talked before about PFAS. So PFAS is a really big problem in the world right now. The forever chemicals, as people call them. They're very difficult to detect. If you can't detect them, you can't do anything about them. That sensor can detect PFAS. So it's going to impact in all different industries, in all different spheres of life, and fundamentally change how we live. And the only thing doing that? A layer of carbon atoms. So it is quite astonishing what you can do with material science.
Crazy.
I mean, I think the range of applications of your technology is just quite mind-blowing, really. How, when you're approaching the market, are you prioritizing what to work on? Because now you've opened this Pandora's box of different application, opportunities. How do you decide which is the right market for you?
I'd like to say we flip a coin, but it's a difficult one. Honestly, it really is. And there's an extra kind of dimension to that, which is even when you have graphene and you have a product, there is still the reticence to adopt that product because there's never been a product like it before. So qualification and certification by companies that what you're making works is a real challenge as well. It's not as simple as just saying, oh, that opportunity is great, we're going to go straight after that. There could be, for example, with medical diagnostics, a 5-year FDA cycle. And that's not really what Paragraf wants to do. Wait for 5 years to see if something's going to be qualified. So there's a lot of, if you like, overlapping circles in a Venn diagram that kind of point you towards what should we do, what's valuable right now, what's near-term valuable, what's valuable for the future, what can make the biggest impact, what's got the biggest benefit to the world. All of these things get thrown into a bucket, and then we go into a boxing ring and have a fight.
The arm wrestle.
Yeah.
Shoot darts.
Yeah, I think the one that everyone's doing at the moment is Mario Karts. Whoever wins Mario Karts gets to pick. Well, we can make Mario Karts faster with faster computers.
Goes all the way back to the description for the 5-year-old.
Exactly. But it is, you're right, it's the most difficult challenge of a business that's got such a horizon of opportunities in front. How do you really understand what's best for now and what's best for the future? And we still have that challenge now. But really, there's an anecdotal example here. We also make magnetic sensors. We started to put them into the automotive industry. And the first question that we were asked was, sorry, can we have the 10-year data sheet for the performance, please? We only made these 2 years ago. How do you provide a 10-year performance qualification data sheet for something that's only 2 years old? And they're the challenges we go through. Again, in the medical industry, is this material appropriate for being near somebody's body, for example? Well, I hope it is, because there's a very good company called InBrain at the moment. They're putting graphene into people's brains, so I'm assuming it's good. Yeah, it's a challenge. It's a challenge, and we'll hopefully pick the right horses.
Watch this space.
What do you think about those more let's say, visionary, almost sci-fi-like, let's call it visions for graphene that came into sort of public light 10 years ago when there were some breakthroughs in the space. Like, I remember reading some popular scientific newspaper as a teenager, and there was like an airplane made out of graphene concept that would be like transparent. You could see everything that you're flying through. See, I don't think passengers would really like to do that on like, normal commercial flight, but like there were all sorts of those ideas. Do you think that there's still something that someone could imagine would happen, or too far into the sci-fi territory?
I've got to ask a question. So you were younger.
Yeah.
Were you reading a scientific journal, or were you reading Wonder Woman? Because she had an invisible plane.
What?
Wonder Woman had an invisible plane. So I was wondering whether it was DC comic you were reading.
No, it absolutely wasn't. It was called Science and I Think Life. So it wasn't like, the Nature.
Yeah.
It wasn't Polish. It was a Polish thing that was gathering the latest scientific discoveries and then packaging them into like a 2-page sort of article with some visualizations, something that was appropriate for a teenager and, inspired a lot of stuff that we're doing now.
I think this is the wonderful thing about the human brain, is that we have this incredible ability to imagine what could be possible. Unfortunately, science in the real world gets in the way of that.
Yeah.
10-year data sheet gets in the way of that.
Exactly.
Well, this would be like 100-year data sheet, I think.
Graphene has some incredible opportunities. If I step outside of our sphere for a second, which is kind of into the area you were talking about, materials for what I would call mechanical applications.
Yeah.
There's lots of companies making mechanical composites, lots of companies making additives into materials that will achieve some of the things that you read about. I believe that graphene will be in a lot of composite materials in the future because it's electrically conductive. The idea for the airplanes, by the way, is all around, can you make very lightweight airframes?
Yes.
But also graphene is conductive, so it's very good should you be flying through lightning storms, for example, discharging energy.
Yeah.
So there is science based in the sci-fi there.
Yeah, but it's not gonna be like all graphene airplane or none of that stuff.
No, unfortunately not. Not in our lifetime, anyway.
Yeah.
That would be a big wafer to make.
Yes, absolutely. But there are a lot of things that are considered sci-fi now, and if you go back in years, when people were using, vacuum tubes as diodes, did people ever think about having silicon transistors and chips? Probably not. But it's the same today. That device, if I take this device as an example, solid state interaction with biological agents in a chip has been theorized since the 80s. People tried to make it out of silicon, but the materials just weren't available. People have tried to make it out of compound semiconductors. Graphene bridged that gap of saying, well, yes, you can make it, but there's a material that's good enough for it to function properly. And so that was sci-fi. You might remember back a term called lab on a chip. Maybe not. Maybe I'm a bit older. But this was kind of, you would put a sample onto a chip and it would have the ability to tell you what was wrong with you.
Yeah, kind of like a doctor in your pocket sort of a thing.
Exactly. And that's what people have been speculating about. Could we have something, even if it's something simple, like you've got a chip that can tell you whether you've got a virus or a bacterial infection? Because if it's a virus, don't go to hospital. If it's bacteria, get to hospital quite quick. But those types of tests are normally done in the lab, so the lab on the chip. That's what this is about to open up, because that's testing for one thing. But if we line a load of chips together and they're all testing for different things, then you've essentially got that capability. And that was sci-fi. And now it's becoming real. But to go back to the point about the different applications for graphene in, let's call them extraordinary spaces. I was contacted in the early days of Paragraf, when we put out some press releases about the wafer scale graphene. I was contacted by a company that makes briefcases. and said, they said to me, "Can you make a graphene briefcase for me, please?" And we said, "It's not really what we do. Can I ask why?"
Yeah.
And they said, "Well, we know that graphene is bulletproof. And so if we put something in a graphene briefcase and we're transporting things around the world," I didn't ask what their business was, "then we can have bulletproof briefcases." And that's one of the things that's come out with graphene over the years. If you remember those early publications, there's a picture of a bullet and graphene being stuffing the bullet. It's not true. It's not true at all. But it made people think it was true. And so we've been down a few of those routes. I've had a few very strange requests for where we can use graphene. But I think that's our job as scientists and engineers, actually. And that's what I truly believe in. We are supposed to be pushing to turn sci-fi into real world. And this is another step forward.
In terms of the climate angle on your work, obviously your work is substantially more energy efficient. That's kind of the foundational piece. But in terms of climate tech, there's lots of potential applications as well where I'm sure graphene could have a huge impact. So thinking EVs, for example. What are your thoughts on that in terms of that kind of wider market?
So the first, if you like, point I will go back to is the energy efficiency of the material. So anywhere you can put that material, you're going to have that energy efficiency. And so maybe I can make a comparison to that. Today, there is a type of sensor called a Hall effect sensor. It's a magnetic field sensor. And there's about 8 billion of them sold every year. They go into mundane things. They go into laptops to show you position and sensing of your laptop. They go into cars to monitor your rotational speed of the wheels, so to give you your velocity. If you could take a single Hall sensor and make it out of graphene, you would reduce its power by about tenfold. Doesn't mean much because they're only using milliamps. So then you're using 10 times smaller. But if it happens for 8 billion sensors, you can shut a power station. And that's just one single sensor, a magnetic sensor. So the possibilities are huge just from reducing power. If we flip it the other way around, which I'm guessing where your question was coming from, there are companies now making graphene-based batteries because the power density and energy density is so much higher. So we're able to transport energy a lot more efficiently, which means that we're not having the power losses that we had before. We're not having the energy losses we had before. There are also people putting graphene now into batteries for next-gen EV batteries, where you're getting higher efficiencies. So there's a whole host of different areas where we can see graphene coming in to not just lower energy, but make everything more energy efficient. And I think that's probably one of the biggest impacts graphene's going to have in the world. It will certainly, in device form, change how industries work, but it will also have a huge impact on how energy is thought about in the world. We're working on next-gen solar cells using graphene. Probably something I shouldn't talk about at the moment, but but they are photonic absorbers at certain frequencies. So you're talking about material that at the moment we worry about. Carbon dioxide going into the environment is a really big problem. Graphene is using carbon to solve those energy problems. So it's a really, really exciting material, really exciting technology. And it won't all be done by Paragraf. We're opening the door to hopefully having other people use the same types of technology. And hopefully we can build an ecosystem and a community around the world that can really harness that power and that capability.
So you said you're creating the market.
Yeah, trying to.
Yeah, yeah, exciting. Let's talk a bit about commercial and the commercial side of your business. I think it's been really fascinating to hear about the journey and the innovation journey that's brought you here. Looking forward, how are you building your commercial strategy? How are you getting customers? Who are those customers? What does that look like for you?
Yeah, that's our, if you like, that's our now challenge. That's what we're going through in the immediacy. In fact, I had a very long commercial strategy meeting yesterday.
Perfect. Just ready for this question.
Yeah, perfect timing.
Exactly. I knew it was coming. Actually, it's about finding those, what I would call early adopters, that are large enough to be of interest for us to create volume product, but also agile enough to be able to bring the product to market that they're using fast enough. So a lot of our effort goes into identifying not just the technology that people want, but the types of companies that we can work with. You can't go to some of the really large corporates without you having to go to a department that then needs to make decisions and then needs to put budgets into things. And before you know it, you end up with a really long qualification chain. You end up with a really long purchasing chain as well. So our thoughts are really around who are those innovative companies. I don't mean, we work with a lot of startups and a lot of R&D facilities, but what I really mean is those mid-level companies that are looking to overtake those top-level companies. So you can go to them and say, if you adopt our tech, you can get to where they are and circumnavigate them. And that's our real strategy, really. How do we entice people to take that risk of using our technology? We don't see it as a risk. They, of course, do. Because they have to qualify a whole new material again, as I was mentioning before. So most of our commercial efforts focus on where can customers use our graphene, but where can we use that graphene with customers that gets us to market quick, gets us getting revenues quick? Because as you may have worked out, my next financing round is going to be very much about revenues. There are a lot of technology companies right now looking for new solutions. The world is a very strange technology landscape at the moment. There's a lot of focus on AI and quantum. There's a lot of focus on new diagnostics. But a lot of the other technologies are getting left behind and people are seeing opportunity. So as I was talking about with the magnetic sensor there, you can't go to an automotive company and say, oh, if you replace all your sensors, you're going to save this much energy. What you need to do is go to the tier one and say, well, you want to embed our sensors into your systems that are going to go into the automotive market, which means you can offer an advantage to that automotive customer. So we have to position ourselves in the supply chain as well. We have to make sure we're not just talking to end customers that want to use graphene, we're talking to the partners that are going to deliver the subsystems that are going to go into those end customers. It's quite a complicated landscape. Most of the time, shouldn't really say this, but most of the time, the customers that are becoming big customers come out of left field. But that also highlights how much you need to advertise your company and what you're doing and how you need to get product marketing out there, because it's not always the people you target that jump first, but people that have been adjacent and watching that move first. So there's a lot of time that goes into product marketing strategies, a lot of time that goes into corporate level marketing. So I do a lot of events just to get Paragraf known. And I carry around things in my pocket just so people get excited.
I was going to ask, actually, was it like specifically for today, or do you just have it in the pocket of your every suit?
I have different things in different pockets of suits, so I'm not quite sure what I'm going to pull out at any one point in time.
Yeah,
but
I looked at something else the last time we saw each other.
I should have brought the wafer with me today, but
Yeah.
Unfortunately, the wafers we have now are highly valuable. So when I talk to my operations team, they don't want me taking it out of the building.
Yeah,
Well,
don't want it just full out your pocket.
Unless you carry them in a bulletproof graphene briefcase.
Now there's an idea. I'm going to start working.
Kat, we cannot talk about the bulletproof graphene briefcase. It's not a real thing, guys.
Yeah, I'm going to have to start working on that now. We have a use for it ourselves.
So commercial is, I guess, something that is becoming much more of a focus for you before the next funding round. On the marketing front, you said you do corporate, you do product marketing. What does that look like for you, and how has that created a positive outcome?
There's a common factor between those two, whether it's corporate or product or marcoms, even internal marketing. There's a common theme that runs through all of them, which goes back to the graphene challenge, which is getting people to understand what graphene is and what it can do. So if we take it from the corporate side, when I go and talk about Paragraf, most of the questions I get, not usually from the audience, they usually happen afterwards, is what's the graphene going to do? How does the technology work? Is it real? I invested in this and it didn't work.
Is it real this time?
Exactly.
I heard it 5 times.
Exactly. So it's educating people on the graph. So you then go to the product marketing where you're talking to customers, you're talking to potential partners. The questions are the same. Does it really work? We've tried this before. What is the properties that graphene deliver? And then you move into the general marcoms of things, and you're talking to whether it's to magazines or whether it's to general outreach. You get the same question: is this graphene going to work? And even when I'm talking to technical marketing publications now, the conversation will finish and the article's ready to go, and I will still get the same question: does this graphene really work now? And so there's a narrative that underpins every bit of marketing that we do, and even internally. If you think the commercial team go out to the customers, our staff still want to know that the customers believe that the graphene works. So it's the same question, just in a different order. That's something that we've had to cope with and understand and actually spend time, energy, and money on to get over not just one hump, but several humps in all of those marketing spheres. We're almost there, I would say. We have customers that come to us now asking for us to do things, as opposed to asking what graphene does.
Yeah.
I go to corporate events now where people will come to me before I've done my talk. No, I've seen Paragraf, you're doing graphene and you're doing it on wafer. So there's been a cycle we've had to go through, if you like. But once you've gone through it, you start to get to a world where you're not talking about what graphene is anymore. You're talking about what Paragraf's going to do. You're talking about what the product's going to do. You're talking about the applications to a technical forum of what things are going to happen. And the staff are going, well, we've got customers, so we don't need to ask whether they understand it or not. And so that's been the real challenge in the marketing sphere, if you like, for us, making sure the world understands what we're doing and making sure they understand that, no, this is not another graphene that is you can put money into or buy and you're just going to throw in the bin.
It's a common pattern that we see across all of the businesses that we work with too. The transition between being early stage and discussing the technology and the innovation, and then moving into just talking about customer problems and how you fit and how you solve those problems. I think it's just a sign of commercial maturity and growth. And like I say, very common with deep tech companies that we work with. Do you find that often when people are coming to you, they're coming to you having followed your work throughout the period, or you're meeting new people now that are hearing of you because of this more recent breakthrough?
It's definitely the former. It's rare for us to have a direct outreach that doesn't know Paragraf already or hasn't known of Paragraf's technology before. That's becoming very rare now. Most of the inbound that we have from customers, they will actually say just what you said. Oh, we've been looking at you for a couple of years. And
we've been thinking about graphene, we've been wondering, and now with those breakthroughs, we just couldn't resist getting in touch.
Exactly. I need to make a see-through airplane.
Is it possible? The briefcase.
Exactly. So, yeah, it's definitely a situation now where the world knows that we're doing something. We do get the odd communication of, we've seen you in this location, or we've seen you doing this. Can we have an opening discussion to see what it's all about? But it's very rarely, what's this graphene stuff anymore? And so a lot of energy has gone into, it's nice to see that the energy that's gone into that is now paying dividends because it's taken 7 years. But there's also, the point you were making about deep tech adoption, you've also got to remember that as much as we like to think we can embrace change, the human mind doesn't naturally embrace change. So even when you're working in high-tech industry, you know the saying, right? No one ever got fired for buying from IBM. we don't like to change. And so that's the deep tech challenge half the time, getting people to change their thinking, getting them to change their mind and go, oh, actually, that might be good. And that's been a big part of our journey for the past few years.
Identifying the champions that will bring you in internally.
And again, it goes back to the concept of early adopters and those companies that see it as their competitive advantage over the incumbents.
Yeah, that's a really good point. If you can invigorate somebody that sees that they can use your tech to get ahead on beyond somebody else's tech, they are the kind of gold mine customers.
And again, they will have bigger risk appetite.
Yeah, absolutely.
Yeah, I mean, we always discuss with our customers, when you're identifying the champion, what is in it for them? What are you selling to them? It might be their promotion. It might be the company's one up on a competitor in some area. It might be a specific company policy that's been publicly announced. So finding what that value point is for the individual and then using that person to help you kind of reach into the company more generally and be introduced in a warm introduction is invaluable.
Yeah, absolutely. We kind of, when we approach companies, we look at it in as 3 different levels. Right? So you have the person that's going to do business development, coming and finding out about your company, and quite often can hand cards internally and say, "Oh yeah, I went to an event and I found Paragraf, and would this be interesting?" Then the next level is the tech champion, like you're talking about, which is the person that really gets what you're doing. Will go to his colleagues and go, "Yeah, this could work really well." And then the next level from that is the person with the buying power. And so if you can get in as those 3 points, I'm not saying you should do it for every company because you can annoy companies by doing it too early or too late. But having those 3 champions, if you like, the business development person wants to make their sales bonus. So if they can bring you in, they will. The tech person wants to know they've invented something new and created something where they are. And of course, the buyer wants to make sure that the top line of the company is, or the decision maker, I should say, wants to make sure the top line of the company is good and they get the reward for that. So we always try to look at how do we get into certain companies in those 3 different channels. It takes a lot of time. And again, in the early days, it meant we had to explain graphene at 3 different levels.
I mean, what you describe, I feel like it's one of those most satisfying things that you can see on some like marketing analytics tools when you're tracking, for example, what companies are visiting websites. And you see that, okay, you had an event, someone came in through like an event-related resource from company you're targeting. Then a few days later, another person, then 3 people at the same time, then someone from the city in which there is the head office, and then someone from the big US office coming through a link, through a referral from internal Microsoft Teams platform. And then you know that, okay, you seem to be progressing somewhere in that company. Maybe you should reach out again, or maybe they will reach out to you.
Yeah, it's monitoring that traction level.
Exactly.
And that's really important. And also then going back and looking at how did you achieve that traction level? How did you actually make that happen? Because a lot of the time it's, what did you actually say to that person that was at that event or that was at that industrial forum? What words did you use? How did you portray what we were doing to get them to go back and talk to somebody? So it's an art, really. And commercial is an art. It's one of the most difficult parts to do, particularly in a deep tech field.
So you're also marketing across different geographies, and particularly, let's take the UK and the US. There's been a huge change in administration in the US and direction. How does your marketing strategy differ between the geographies in which you work?
Well, we have an entity in San Diego, and we have US staff in the office. It's an interesting question because a lot of people assume that the culture between the UK and the US is very similar. We speak the same language, but actually the cultures are very, very different. We don't sell a lot in the UK, so our marketing is not really targeted that much at UK customers. In fact, it's mainly targeted at Asia, where there is very specific marketing approaches and approaches to the different levels within companies that you have to apply. Japan is very, very structured. China, you kind of need to get in with some of the local administration to make headway there. Taiwan is very straightforward. So marketing towards the east, if you like, if I could take the question that way, is really targeted specifically at countries whether we want to be very technical, and usually it is in all of those countries. Very technical communication, very application orientated communication, very kind of immediate downstream talk of what we would do together. The US is different. The US, you have to be very strong-willed. You have to be knocking down the doors. You have to be willing to pick up the phone. And that's a challenge for UK people, picking up the phone and just speaking to somebody.
I remember we had some conversation about that when we just started business, with myself being Polish, Kat being as British as they get.
It is a challenge and that's the cultural difference. If you're in the US, if I ask one of our staff in the US, oh, can you talk to this company? They'll go, yeah, just give me a few minutes. I'll pick up the phone. They'll have a chat and they'll come back with the answer. In the UK, we'll send an email. So the US communications, the US kind of marketing and strategy for product is very much around making sure you have good dialogue, you have good conversation, you're very upbeat about what it is you're doing. Not technically upbeat, but upbeat about, well, this is what we can do together. This is how we can work together. That wouldn't work in Japan. Japan, you have to have all the tech sheets, all the spec sheets. And so there's a very, very different cultural alignment on product marketing. Now, if we're talking investment marketing, then that's different as well. So you have to have big vision, big picture when you're in the US. You have to be able to commit to what you're doing, and people have to feel that you're committed. They have to see it in your face. They have to see it in your eyes. They have to believe with you that you're going to do it. In the UK, nice business plan, nice hockey curve, nice set of statistics that you're going to achieve. Here's our objectives. It's very more formal. I'm not saying one is better than the other, but that's just, you've got to be able to communicate in those two different ways, because as I mentioned before, when you go from innovation capital, the early stages, into the later growth capital, you're going to have to be able to talk on both sides of the pond, or you're not going to get there. So it takes a while to get used to. A lot of psyching yourself up before you talk to an American investor. And the other big thing, maybe I shouldn't say this, but you get less time to talk when you're talking to an American investor than you do with a UK investor.
Okay, so it has to be this very sort of hyped up kind of test of belief and communicating that belief, rather than a deeper discussion and a debate on the topic.
Yeah, absolutely. Well, the elevator pitch is a US thing. 3 minutes, tell me what it is, get it all into that nice package, and I understand what you're doing. I remember when we started Paragraf, people were talking about, can you do an elevator pitch? And so you spend some time putting an elevator pitch together. Not a single one of our first investors asked me for an elevator pitch. They wanted to get to know more about it. They wanted me to sit down and talk them through it. But when I've talked to American investors, US investors, then yeah, the elevator pitch is a really big thing.
Yeah, they're like, are you worth more time?
Exactly.
Than 3 minutes?
Exactly.
I'm so sad to say that we're coming to the end of our time. It's such a shame because it's such an interesting conversation. But before we finish, do you have any shout outs for our audience? Where can people find you? Leave us with a message about Paragraf.
Sure. So I've talked about growing an ecosystem around graphene, about how we've had to educate the world. The big goal for me is to find partners that have got innovations that they believe graphene can help in. So electronics mainly for us, because that's our sphere. So if you've got any ideas about how you might want to bring graphene into photonics, into electronics, into diagnostics, or if you'd even like to just take a look at what we're doing and get a better idea, go to our website. The products are there for you to look at. We even have data sheets now. But we're really looking to expand the whole benefits that graphene brings to the world. And that's not just about having one target customer or one corporate customer. It's about spreading what graphene can do throughout the ecosystem, throughout the community. So please do come and visit us. Come and have a look at our website. In fact, if you want to, come and visit us. We're an open door. We love to bring people around and show what could be the potential future using new materials.
Idea for a company day away?
Please come on over.
Our team would love it.
Yeah, absolutely. Okay, thank you so much for your time, for your insight. This has been great. And thank you, Matt.
Thank you very much, Kat, and thank you very much.
Thank you both. Really appreciate it.
Okay, we've done enough thank yous now. I think we can catch everyone else on the next episode of Scaling Green Tech. Goodbye.
Bye-bye.